The new service is done, tests pass, the team is confident, and it has been running in staging for weeks, doing exactly what it should. None of that is evidence. Staging traffic is traffic you imagined. Production traffic is traffic that exists, and it contains the request shapes nobody thought of. The customer whose record has been broken since 2011, and the volume you did not model. So the cutover is not a deployment. It is an experiment, run against the only environment where the answer lives, and the whole design goal is that when you are wrong, and you will be wrong, the cost is a config change rather than an incident. First step, and it is free. Deploy the new service and send it real production traffic, but throw the answer away. The facade calls the mainframe, returns the mainframe's answer to the customer as it always has, and also calls the new service and discards what comes back. Nobody is affected. The new service cannot hurt anyone because its output goes nowhere. And yet you are now learning the only things that matter. Does it fall over under real load? Does it handle the request shapes that actually occur? Does it have a memory leak that appears after 6 hours? You get all the information of being live with none of the risk of being live. If you skip any step in this episode, do not skip this one, because it is the one that costs nothing. Now make it useful. You are already calling both, so compare them. Log every case where the new service and the mainframe disagree, and go and read those. This is the step that finds what your tests could not, because a difference is a fact about the real system rather than a guess about it. And expect most of the diffs to be your own misunderstanding rather than bugs. The mainframe rounds differently. It returns a value in a different order. It has a rule you did not know because nobody knew. Some of those you will fix in the new service. Some you will discover are bugs. The business has been depending on for a decade, and now you get to have that conversation with evidence in your hand rather than a suspicion. When the diff rate stops moving, you are ready, not before. Only now do you serve the new answer, and you do it to 1%, then 10, 50, 100, watching error rates and latency at each step, and pausing at each step for long enough to see a full cycle of real usage, because a problem that only appears during the overnight batch will not show up in the 20 minutes you spent staring at a graph. 2 rules make this safe. Rollout by capability, not by release, so a problem in balance checks never touches claims. And rollback must be a config change, not a deploy, because at 3 in the morning, the difference between reverting a value and shipping a hotfix is the difference between a shrug and an incident. If your rollback needs a build, you do not have a rollback, you have an intention. And underneath all of it, the thing that makes cutovers genuinely hard, the data. While traffic is split, both systems are writing. If they own separate data, fine. If they share it, or worse, each keep their own copy, you have to decide who is the source of truth for each field, and the answer has to be one of them, not both. The pattern that survives is a single writer per piece of data, with the other side reading or syncing, and you migrate the writer as its own step, separate from migrating the traffic. Doing both at once is how you end up with 2 systems that each think they are authoritative, disagreeing about a customer's balance, with no way to tell which one is right. That is not a rollback situation. That is a reconciliation project. So the traffic moved and nobody noticed, which is the highest compliment this work ever gets. And now you are at 90%. The interesting problems are solved, and the mainframe invoice has not changed by a cent. Next episode, the finale, the last 10%, which costs more than the first 90, and the decommission nobody budgets for. See you there.